There was a time when the night sky was a book, open and alive, before cities washed it pale, before satellites drew scars across its pages. To those who looked upward with naked eyes and wondering hearts, the stars were more than distant fires. They were signs, gods, omens, storytellers, and one among them stood apart. It flared suddenly in the dark, brighter than Venus, bold enough to cast shadows. It arrived uninvited, unfamiliar, a cosmic stranger that made even seasoned sky watchers pause. In deserts, valleys, and palace courtyards, it became the whispered question, "What is that?" It stayed. Weeks, perhaps months, burning steady as if trying to be remembered. And then, just as it came, it was gone. No slow fading, no trace left behind, only silence and stories etched into memory. In China, court astronomers recorded a guest star that outshone the moon. In the Middle East, scribes carved its brilliance into stone. In Europe, it passed like a phantom, a rumor flickering at the edge of vision. Yet none could say where it came from, or where it went. Today, astronomers gaze through telescopes 1,000 times more powerful. They chart pulsars, galaxies, even the faint whispers of the early universe. But when they search the patch of sky where that star once burned, they find nothing. No remnant, no echo, no name. Just the question. How does a star vanish without dying in light? Perhaps some deaths do not announce themselves. Perhaps in the vast theater of the cosmos, some curtains fall in silence, and somewhere in that darkness, the story waits to be told. Before telescopes, before equations, before we understood the nuclear heart of stars, there were eyes. Human eyes turned upward in stillness, watching, waiting, wondering. Ancient sky watchers were not distracted. They read the heavens like scripture, and when something new appeared, they noticed. In the summer of 1054, Chinese astronomers marked the sky with trembling brushes. In the constellation Taurus, a brilliant light appeared. So luminous it was visible in broad daylight. For 23 days it burned beside the sun. At night, it ruled the heavens for almost 2 years. The scribes called it a guest star, a celestial visitor, bright as the moon. But China was not alone. In Japan, monks recorded a similar anomaly. In the Arab world, a few murmured of a heavenly flame that bloomed and vanished. Even in the American Southwest, in a cave beneath the sandstone cliffs, a Puebloan artist drew a radiant star beside a crescent moon, frozen forever in ochre. They could not know what it meant, but they remembered. And then, time passed. Empires fell. The guest star faded from memory, from maps, from meaning. Its light, once brighter than the full moon, was swallowed by the centuries, until a strange cloud caught a young astronomer's attention. It was 1921. Edwin Hubble was yet to unveil the galaxies. Einstein's theories were still rippling outward, but in the heart of Taurus, something ghostly shimmered, a tangled cloud of gas, delicate, electric, almost alive. It pulsed in soft colors, whispering of an ancient explosion. They called it the Crab Nebula. But it wasn't the shape that mattered. It was the location. Here, in the exact place where the 1054 guest star had blazed, was the smoking ruin of a star's death. Astronomers were stunned. The puzzle pieces seemed to fit. The guest star, it seemed, had been a supernova, a massive star dying in one final brilliant act. And this nebula, still expanding nearly 1,000 years later, was its glowing tomb. The mystery had a name now. SN 1054, the supernova of 1054. AD, but in every solved mystery, a shadow remains. The Crab Nebula became a model for stellar death, an example etched into textbooks, simulations, and observatories. But its story posed a deeper question. If a supernova could shine that brightly, visible in daylight, why are there not more like it in historical records? Only a handful of guest stars appear across thousands of years of skywatching. Some match known supernova remnants. Others do not. Some have no remnant at all. The Chinese recorded strange stars in 393 AD, 1181, 1572, and 1604. But the remnants of these cosmic deaths are faint, if they exist at all. And after 1604, silence. No bright supernova has lit the skies of Earth in over 400 years. Yet we know, from physics, from models, from observations of distant galaxies, that supernova should occur in our Milky Way every 50 to 100 years. So, where are they? Have we missed them? Did they die shrouded in dust? Did light reach Earth only to be drowned in daylight or lost to stormy skies? Or are some stars vanishing in ways we do not yet understand? In 1985, astronomers launched sensitive X-ray and radio surveys to probe deeper. They searched the galaxy's heart, its spiral arms, its obscured zones. They found remnants, cold, faint, distant, of stellar deaths we never saw. Supernovae whose light was muffled by interstellar dust or never reached Earth at all. But even with dust accounted for, the numbers didn't add up. We should have seen more. And then came a chilling possibility. What if some stars don't die in light? What if some collapse inward so swiftly, so quietly that the universe doesn't notice? A failed supernova, a silent death. A star implodes, forming a black hole with no explosion, no light, no warning. The only sign is absence. Vanished star. For now, the crab remains the most vivid echo of the vanished light recorded in ancient eyes. Its filaments stretch outward like the fingers of time, glowing with trapped energy from a millennium ago. Its heart pulses, a neutron star spinning 30 times a second, a cosmic drumbeat marking the death of something once glorious. But it is not alone in that sky. Others have come and gone, unnoticed or forgotten, and some may be disappearing. Still, without stories, without names, without fire, if the ancients saw more than we remember, if the stars can die in silence, then what else has this sky forgotten? And what secrets are still unfolding, just beyond the veil of light? In the cathedral of the cosmos, stars are the stained glass, burning, colorful, eternal seeming. But nothing eternal burns. All stars die, and most go loudly. A supernova is a cosmic roar, a billion suns flaring at once, a heartbeat that echoes through light years. Others end more quietly, shrinking into white dwarfs, cooling over eons. And some collapse entirely, folding into black holes, not death, but erasure. Yet even these leave behind fingerprints, X-rays, gravitational, waves, distorted space, but what of the ones that leave nothing? What of the stars that simply vanish? For decades, astronomers built a record of the night sky. Photographic plates, infrared scans, ultraviolet signatures, X-ray bursts. Like cosmic archaeologists, they mapped the heavens through time, comparing what was to what is. And somewhere, in those comparisons, a ghost story emerged. It began with a whisper, a question. Why do some stars in old catalogs have no counterpart today? A pattern emerged. Not one anomaly, but dozens. Not an accident, but a suggestion, a signal. In 2017, a team of astrophysicists launched a project with an unusual name, VASCO, the Vanishing and Appearing Sources During a Century of Observations. Their goal? To cross-reference 70-year-old sky surveys with modern observations, searching for objects that had changed. Not dimmed, not shifted, disappeared, and they found them. At least 100 stars listed in mid-20th century catalogs no longer appeared in the same location, or any location, in contemporary surveys. Not just invisible to optical telescopes, but absent from radio, X-ray, infrared, and gamma scans. Gone. At first, the explanations were earthly. Errors in the original data, misidentifications, faint stars missed in newer surveys, but some anomalies resisted simplification. One star in particular, listed in the 1950s, was a prominent object, unmistakable in brightness and position. Today, it does not exist in any spectrum. It hasn't dimmed, it hasn't moved, it is simply not there. The implications are staggering, because stars don't just vanish, unless something unnatural or unknown makes them. Theories bloomed in the vacuum of certainty, some grounded, some unsettling. Variable stars can change their brightness, sometimes drastically, but not to non-existence. Thick dust clouds can obscure light, yes, but not block all forms of radiation. Failed supernovae, stars that collapse directly into black holes, might explain some disappearances, but these should still produce gravitational echoes. And yet, in the VASCO data, silence. No gravitational waves, no neutrino bursts, no lingering radio ghosts, just cosmic amnesia. Then came the speculative frontier. Some physicists considered quantum collapse scenarios, rare theoretical phenomena where a star collapses inward so perfectly that no light escapes. Others invoked vacuum decay events, a shift in the universe's underlying field that might reset matter itself, deleting a star from reality. But one idea sent chills deeper than the rest. Megastructures, Dyson spheres. Imagine an advanced civilization, far older than ours, building a shell around its host star to capture all its energy. To outsiders, that star would slowly dim, and then vanish as its light was completely absorbed or redirected. No radiation, no heat, no flicker. To a telescope, it would appear as if the star had ceased to exist. Not from death, but from deliberate concealment. Was this science fiction leaking into science? Perhaps. But the VASCO team, sober, skeptical, data-driven, did not dismiss it. Instead, they cataloged the possibilities, labeling them not as answers, but as hypotheses worthy of scrutiny. Because the universe had misled us before. It once told us Earth was the center. It once told us time was absolute. It once told us the atom was indivisible. Now, it shows us stars that have vanished, and dares us to explain why. In some cases, follow-up investigations resolved the mystery. A star reappeared obscured by an unexpected dust veil, a coordinate mismatch corrected an apparent absence. But not all. Some stars remain missing. No counterpart, no data trail, no explanation. Like the light of a candle snuffed out, not burning lower, but absent altogether. And somewhere, one wonders, is the star that once haunted the eyes of ancients, the one that flared in 1054, or perhaps another, further back still. Its memory etched in legend, but its source erased. It forces a new way of thinking. Perhaps not all disappearances are deaths. Perhaps not all silences are natural. And perhaps, in the vast dark sea of the universe, there are predators, not of flesh, but of matter and light. Civilizations too advanced to see, but not too advanced to see us. Or perhaps this is simply what the universe does when no one is looking. It changes its script. It deletes its own past. It forgets. One of the VASCO researchers wrote, "We may be witnessing astrophysical phenomena unknown to modern science, or evidence of a technology beyond ours by orders of magnitude. Both possibilities are unsettling. One threatens the limits of our understanding. The other threatens the notion that we are alone. Neither sits easily in the human mind, but the data remains. Cold, peer-reviewed, unexplained, and so the search continues. Night after night, eyes scan the stars, but also the places where stars once were, places that now stare back with absence. Not a fading, not a shift, but a void, an echo that refuses to resolve. Perhaps the sky is not just a map of what is, but a graveyard of what was. A story written in both presence and deletion. And somewhere in that silence, a vanished star still waits to be found, or never meant to be seen again. Light does not forget. Even when the source fades, light continues, moving, stretching, softening across time. Every photon that escapes a dying star is a traveler, bound for a destination it will never know. Somewhere, a beam of light from a vanished star crosses a desolate region between galaxies, a ribbon of memory in a cosmos that rarely remembers. Perhaps, in 1,000 years, that same light will graze the surface of a world orbiting a quiet sun. Perhaps an eye will catch it, a lens will bend it, a mind will wonder, what was this? Who sent this flicker from the dark, and though the star is long gone, it will speak again, not in sound, but in shimmer. Astronomers know this truth well. When we look at the sky, we do not see stars as they are. We see them as they were. The Andromeda Galaxy, 2.5 million light-years away, shows us its ancient face. Betelgeuse, 642 light-years distant, may already be gone. Every glimpse of starlight is a time machine, a telescope looking not into space, but into memory. And if a star vanished, whether in fire or in silence, its light still races onward, a cosmic obituary with no destination. The Crab Nebula pulses at the center of this remembrance. Its filaments of gas and dust, still expanding from a death seen in 1054, glow with a ghostly persistence. In its heart spins a neutron star, collapsed, dense, and steady, beating like the last breath of a world that once was. That light, the X-rays, the synchrotron glow, the whispering radio waves, is the echo of collapse, a death that still sings. And beyond the crab, in the blank patches where stars once lived, there may yet be echoes we haven't learned to hear, not in brightness, but in distortion, not in presence, but in memory encoded in gravitational ripples, in ancient particles still in flight. But this is not only a cosmic story, it is a human one. Because we, too, refuse to forget. We comb ancient manuscripts for signs of lost stars. We scan the sky again and again, trying to match what once was with what remains. We build instruments that reach farther, wait longer, listen deeper, as if memory itself were a form of science. In Babylonian clay tablets, in Chinese scrolls, in a cave drawing beside a crescent moon, the vanished star still lives. Not in its own light, but in ours. Because what is a star, really? It is hydrogen, yes, gravity, fusion, but it is also story, symbol, presence, a silent companion to those who've lived and died beneath its gaze. When a star vanishes, something in us recoils, because in its absence we glimpse our own. A fear that what burns brightest can still be forgotten. So maybe the universe forgets. But we remember, and in that remembering, we give the star a second life. Not in fire, but in myth, in inquiry, in wonder. A star that vanished still shapes us, still pulls our gaze upward, still asks the question that haunts every civilization under the sky. What else is out there that we no longer see? Light may fade, but meaning does not. And so long as we search the sky for what is missing, no vanished star is truly gone.